So it's going to land on the surface while the surface is moving independently of it. At the same time, you're going to leave the moon's orbit as you descend. So the moon is going to continue to do its orbit around the Earth. You're not being dragged along with the moon in lockstep around the Earth. You're no longer in its orbit.
I would say falling towards the moon is being dragged along.
Yeah, you're being dragged along.
Wow, so it's basically in orbit all the way down.
No, you have tangential velocity all the way down. You have momentum conserved all the way down.
So if I was to write an X on the ground,
are you thinking you're going to fly off? Are you thinking you're going to fly off into the space or something?
I know that the moon would be moving independent of me.
Okay, well, no, it isn't, because you know what it has? It has something called a centripetal force. The centripetal force is the object's weight. It doesn't need an atmosphere. We have the same situation. We're flying planes at super high altitudes, a very little atmosphere, but just enough to fly the plane up. But it doesn't mean it loses control. You're using the surfaces of the airplane to control it and imparting momentum in that atmosphere, which acts on the airplane, which gives it ability to be controlled. On the moon,
so 1/6 gravity.
Let me finish. When we're on the moon, though, we don't have any atmosphere. So what do we use to control ourselves in our directions and our attitude with the lunar lander? We use these thrusters, which act the same way as we would be acting on the wings with thrust from the imparting momentum of air. We don't have air anymore. So all we're using is the thrusters.
Side thrusters to make it move the same speed as the ground, sideways, as it's going straight down.
As the moon orbits around the Earth.
We're going around the equator of the moon. The tangential velocity is 10 miles an hour. We're going against it. And all it means is all we have to do is not slow down for the final 11 miles an hour, and we will be in sync with the moon. Because it's already going against.
So wouldn't the orbit and the rotation have to be in the same direction?
We have less velocity to worry about because it's going against us at 10 miles an hour.
Wouldn't the orbit and the rotation have to be in the same direction then?
Yes, that's what they do that. So you don't have to worry about having to fight the extra tangential velocity of even the 10 miles an hour is something they worry about. I don't know if that's even worth worrying about. I don't know for sure they even do that. It doesn't really matter because it's only 10 miles an hour. If it's 1,000 miles an hour like on the Earth, they do have to worry about it. So that's why they take off with the direction of the spin, and they also land with the direction of the spin because it saves fuel. But they don't. They don't do it the other way. But now on the moon, it wouldn't matter because we're talking about 10 miles an hour, not 1,000 miles an hour.
Dude, the ballers are gonna like agree with him too. So
yeah, because he's right.
It's reality,
dude. Oh my gosh, bro. Okay, so you guys are claiming that the moon is spinning in the same direction that it's orbiting the Earth. That they send the rockets to, which is not true. It's not true because you haven't looked that up at all. You made that up. Okay.
Make what up? What did I make up?
That the moon is rotating in the exact same direction relative to the module as it's orbiting. It has to be in the same direction. It has to be in the same direction, buddy. It has to be in the same direction.
Are they at the equator? Are they?
Yes.
Okay. So if they're at the equator, that means they're landing somewhere near the equator. That means they're going in with the direction 10 miles an hour. That means all they have to do is worry about landing 10 miles an hour slower than the rotation of the Earth net. It just saves them a little bit of fuel, not much, to be able to descend. They have thrusters that show you can actually modulate the descent rate and position left to right. It's steerable. It's got full 3 degrees of rotation, of flexibility to be able to move.
They got the same problem. It doesn't even matter about the moon because they got the same problem landing on Earth. There's no sides.
No, but when you use their argument about the Earth against them on the moon with no atmosphere, it's so bad.
We're not talking about Coriolis. We're talking about
at home or on the moon.
Guys, listen.
Whenever you talk about like syncing up, if you were ever even like teasing at the idea that the plane or the lander would be out of sync at any point with the spin of the Earth or the moon, you're just gonna constantly be trying to bend over backwards to find excuses and then calling people morons because they don't understand how it would work perfectly when it wouldn't work at all.
You're so wrong. You're so wrong. Listen. It's really kind of funny. I'm getting entertained by this, but it's getting a little old now for a second.
It's so just funny. Because the Earth would be out of sync.
Can we please mute him? For all that is holy, please mute him for a second. Thank you.
You gave me a headache, so I'm just.
I'm only yelling because he's talking over me. Let me just.
I'm white noising you now.
When It has weight. It's falling to the ground. All we do is control that rate of fall with these thrusters. We can slow it down by adding a force opposite to our direction of travel relative to the surface of the moon.
It doesn't work though, because if I drop an object on the Earth, okay, it has weight, and the moon has 1/6 of that. If I drop an object to the Earth, the reason that it's going to fall down and land right on the X underneath where I dropped it is you guys claim it's moving through the air, and the air is being pulled with the Earth.
No, so it's a non-factor because it doesn't matter whether there's air or not. If it had no air, the same thing would happen.
Really? So you're claiming on the Earth?
Hold on. If the air is moving with the Earth, it doesn't matter because every molecule of air along its path will be in a gradient speed that gives you the exact same tangential velocity, or the same position as it's falling down, because you have a different. Hold on, guys. Let me finish. Stop. Every inch you go higher, you'll have a different tangential velocity if you're going to stay in the same spot above the surface. And that's what would happen. Now, if you don't have any air, that's not a problem anymore. You just go straight down to. If you're orbiting, and you want to fall down, you will have you start with a higher tangential velocity. You have to slow down to actually hit the ground. It means you will be going faster than the ground, and that's controlled by the thrusters. Same problem, easy solution. It's not a big deal.
Yeah, not a big deal. You just have to be in complete perfect sync.
If you're right above, me. Let's say you're 1,000 feet above me. There will be several inches. If I was to go straight down, like you beam me down, it's another Coriolis effect, by the way. It's also Coriolis. Come straight down, you will have a higher tangential velocity, so you'll be going faster than the Earth's surface. But if you were to slow yourself down by whatever means, parachute or wings or flapping your legs or whatever you could do, you would slow that little bit of difference. Maybe 1 inch, you'd be off target. They tried this. They did this. They dropped down. They've done this off of buildings and down deep tunnels or deep holes in the ground. You drop something and it deviates a half an inch or an inch or so, depending how deep the hole is. This is a test they've done. So you're like fighting this. There's the atmosphere doesn't matter.
Just pointing out the obvious.
It doesn't matter. New perspective. It doesn't. If you're flying on the equator and you're trying to land, all you do is slow the aircraft down or the spaceship down, the lander down, so that it just reaches the same tangential velocity as the surface. If you do that, you will land and stop, and your momentum will be.
You admit that if they're not in the same tangential velocity, a big problem, right?
They aren't. You're going way fast. I told you you're going 2,000 miles an hour where the surface is going zero to 2,000 miles an hour. It's a huge difference. They've slowed
the surface going zero.
Zero. You got that right.
The ground is going zero.
Earth is going zero. Right. It doesn't.
The Earth is going zero, and
you admit that.
Now and up in here is going zero. What?
Yep. Earth is
when
not
you're landing,
moving.
You're going 500 miles an hour. Earth's zero.
Yeah.
When you land and stop, you're going zero. Please stop.
Earth zero, bro. The Earth is moving 0 miles per hour. I agree.
Yeah. Can't you see it's moving zero, you moron? Don't you get it?
All right, then you're going 1,500 miles an hour, and the Earth is going 1,000. No matter how, it's all. You guys have a problem with relative motion. Major problem. You need your heads examined. Seriously, this is really a challenge
because
for you.
we're pointing out an obvious problem you can't answer. And
Okay. Let me rephrase it then. So on the moon, it's going 10 miles an hour, not zero. But and your speed when you release is 2,000 miles an hour plus 10 relative to the ground. So all you have to do is slow that 2,000 miles an hour down to 10 miles an hour, and you land on a non-moving surface, which is still going 10. Does that make more sense to you for some reason?
No, because the Earth is moving no matter what. You have to be moving with it, either if it's the moon or the Earth. You can't say it's not moving. When you land
on the equator, if you were landing on the equator going eastward, what happens? If you're going 1,000 miles an hour eastward,
because the Earth's not moving, there's no problem. The only reason that it would be no problem is because the Earth is moving zero. Like
flying in the air,
that's the only way it wouldn't matter.
Dum-dum, you're flying in the Earth. You're flying out over the Earth in the air that's moving with it. So if you're flying in air that's moving 1,000 miles an hour, and you're in an airplane going 1,000 miles an hour, and the Earth is spinning at 1,000 miles an hour, that means you're really flying 2,000 miles an hour. So you slow the plane down. Hold on, let me finish. This is why you don't know anything. You keep on talking over me. So if you slow the plane down 1,000 miles an hour, you will be going 1,000 miles an hour when you land, but zero relative to the ground. Why is this so hard to grasp, guys?
Because you have to be moving sideways at 1,000 miles an hour in perfect sync with the Earth. Also slowing down. to land the
you're a little
plane,
slow.
which
You're a little
slowing down
slow,
to
aren't
land the
you?
plane,
You're
you're
a
going to
little
lose the
slow.
momentum and you're going to be out of sync with the Earth. Even
You're
if
a
you're
little
a
slow, aren't
mile,
you?
1 mile an hour
We're on
an
the
hour, it
equator.
doesn't matter.
Oh my
They
God, Winston, I
never,
can't
they
take him.
never
You're
have
bad
to
enough.
do
He's
that.
worse.
Zanick. Left lane never has to do that, never has to think about it, never gets trained to do it. No flight simulator ever even includes that. The only reason that would be the case is because the fucking Earth isn't moving, dude. If it was moving and you had to time it, then left lane would know all those things. He would be trained to do that. It would be a big concern. It's a life and death matter. It's not like I'm a moron for not fucking getting it because it doesn't move. That's the only way it
I
works.
fly as well.
admit that.
You fly point to point. You're full of shit.
Oh, yeah.
You're really
Point to
confused.
point.
And you're a
Now
little on
it's
the,
just point
you're on
to
the
point.
low. You're on the
Now
low
it's just
IQ
point to
side.
point. You don't have to worry
You're
about
on the low
timing it.
IQ
You're
Or
getting
side.
really
Just
emotional,
trying to-
Zanick.
I'm a low IQ because I'm pointing out the obvious, and left lane was never trained to do any of these things. And then you say, oh, well, he just has to follow the ground path and it fixes it for him. Even though I'm complicating it all by saying all these things have to be fixed, but then he doesn't have to worry about it. It fixes it for him, right? That makes no sense. You're totally contradicting yourself. You have no right to call anyone a moron. You're bending over backwards with excuses that don't make any sense. You're making shit up. I don't know if you're paid to do this or what, but you are fucking ridiculous.
Wow, that's really funny. It's a humorous.
No,
to me
it's not funny.
because-
It's
because
actually
I've
really
given
kind of
you
weird.
I've given you the exact way and methodologies you could look
Let's call
at.
left lane about
To be
it.
able to understand this, you're not even listening. All you're doing is talking. I'm telling you, if you're on the equator going eastward and the Earth is spinning at 1,000 miles an hour and you're going 500 miles an hour, the total speed of you from the inertial reference frame would be 1,500 miles an hour. But because we're also landing on this object that is traveling that fast and we retain momentum, all we have to do is slow our plane down 500 miles an hour. We'll be going 1,000 miles an hour tangentially. So will the Earth. That means we're going at zero ground speed. That means we stop, come to rest. All we have to do is slow the plane down 500 miles an hour and land the plane like anyone else would think we would do. Nobody needs to train for that because there's no problem with flying in the air mass.
No training necessary.
Earth. Now, even if we didn't have the air mass, it wouldn't matter even still. We would use thrusters to do the exact same change of momentum and change
Side
of
thrusters,
force to be able to land on the Earth without an atmosphere. No different than on the moon, which is done the same exact way. You are completely confused and very low
They
IQ.
have side thrusters to keep they have side thrusters to keep the lunar lander going sideways with the moon as it's also going
Why
down.
are we
slowing
moving
it down to go
sideways with the
straight
moon? We're
down.
going with the spin.
And
We're
there's
going,
side
hey,
thrusters
dum-dum,
because
dum-dum,
it's going
dum-dum.
it's
We
landing
are
on a
going with
north
the spin.
landing on a north
You
runway.
keep on saying that. We're not going
Landing
north-south.
on a north
We're
facing
not going
runway at the
south-southwest.
equator.
Keep
It would
on
have to be moving
confusing. We're
sideways
going,
1,000
we're
miles
going,
an hour.
we're going in the direction of spin. We're not going north. We're not going south. We're going direction of spin. Completely
What?
perpendicular with the axis of rotation.
The runways are facing every direction. What if they're
No,
facing
on
north?
the
and you're like,
moon. On the moon, we're not going every direction. We're only going
you
one
would have to have
direction
side
with the
thrusters to
spin.
keep your
We're
momentum
only going with
going.
the spin. Hey, dum-dum. We're only going with the spin.
Dum
Why
dum.
is this so hard for you to understand?
I'm not. I'm listening
You
to
are a
everything you're
dum-dum.
saying.
You really
Everything you're
are.
saying doesn't make any sense.
Why,
Calling me a dum dum is
you
your
are dumb.
way
You are
of
dumb.
trying to make it seem like you're.
I had a lot of dumb
you're
conversations
wrong.
on this server, and this is the dumbest. I think this is the. I mean, all the other stuff like
Yeah, it must be because you have
length
no
and
answer.
traction stuff. That's all great stuff to talk about because there's a lot of debate, a lot of theory. This is just basic, simple
Just
kinematics.
basic,
Very
right?
basic, simple kinematics.
It's
You
basic
guys,
that you think
relative
left lane
motion
would be taught about all these
simplest
things.
first level degree. This is first grade
Basic training for how
relative
to
motion.
fly.
First grade relative motion with one factor, a vector of weight. That's all we have here. Two
That's all
two
you have to
elements to
worry about.
understand. You can't understand
Those
either one of them. Unbelievable.
Yeah, unbelievable.
Seriously, dude.
You can't
I hope your
explain it,
mother
but you
must be
act like
ashamed
you
of
can.
you. Did she disown you
Oh,
when you were
okay.
younger?
Right? Yeah. See,
She
that's
must have put you
your
up for
trigger.
adoption. I would
You
have.
have to run to that. You have to run to that because you have no answer and you know it. Sad.
Yeah, what's it? Why don't you look at what's just posted by Earth's Life? Does the Earth axis?
This is
moon,
this is
does
totally. I think you're right.
Does the moon axis?
Checkmate.
Does the moon axis?
Checkmate with it.
Hey,
They can't
does the
land a
moon
plane
spin
on
on
the
the
Earth, and they
Fuck
can't land a
you!
lunar
God,
on the
big mouth.
fucking moon. It doesn't
That's
work. They
hilarious.
have no excuse. They have no reason to fucking make it with it.
They're
The fact that
moonlighting
he's trying to
tonight.
make up things and act like we're dumb, it just shows that he's like just brushing the
Wait,
pieces
so you got to
off
move
the board.
your buddy's dumber than you are. I mean, this is really bad.
Oh yeah.
Moonlighting denier.
Okay, so Witsit, can we go back to our discussion because he doesn't want to even think about things. At least you're trying to think.
Oh
He's not.
yeah, I don't want to think about things, even though I totally fucking outed you
Hey, can I
over
say
and over
something?
again.
Can I say something real quick and then you can get back to it?
Oh no! Oh my God! Can't wait for this. Go ahead.
Well, this is interesting because Witsit says, if I understand correctly, that there's no perceptible difference between a geocentric and a heliocentric coordinate system.
According to your own
And
belief, yeah.
and New Perspective says that there is a difference when a plane is flying over a rotating Earth, even though it's the same difference of coordinate systems. So which one's correct?
I said according to your
Well,
own
it's not.
belief system, you have to claim that it's geocentrism is just as valid. I obviously don't believe that heliocentrism is valid at all. And his reason is
Yeah.
just one of the many.
Yeah, I don't think the Earth spins at all, so I'm not claiming anything about what it does or doesn't do. I'm just saying that it's not spinning. It couldn't be spinning, because if it was, there would be plane crashes all the time. And left lane would be trained
Why
to
would
worry
that
about all the
happen?
things
Why would
that
it crash?
Zanick's talking about. Because they would be landing on a moving surface, and they wouldn't be accelerating sideways at the same tangential.
How much is it moving?
Because you don't conserve momentum in that way. You don't add to your momentum, bro.
Momentum's always
It's just the
conserved.
way it works. I'm sorry, I don't know how to tell you
not
this.
the
I
way
mean,
it
you're in a
works
plane, you're
at
in
all.
a plane. You should know. You never have to worry about the fucking conserved momentum or the
You do.
tangential speed. Those are things you never have to worry
You don't have
about.
to worry. Yeah,
You can say
you
it's
don't have to
because
worry
you're
about
following the ground
it. You
speed.
don't worry about it because it's always
Well, if you
conserved.
don't, well, then what are you even talking about if you don't have to worry about it?
Because you don't have to worry
Basic
about
physics.
it. Because basically, you keep on talking about a change in tangential velocity, which would be an increase in momentum that you'd need if you did it all at once. Like you beamed you directly in a straight line, like a projectile. But you're not a projectile. You're flying something with controls. And along the way, you're flying point to point. And along the way, over 15, 20 hours, going from North America to the equator, you will slowly be moving to the east. And that slow movement to the east gives you additional tangential velocity, i.e. momentum. And by the time you get there, there's no problem. You're flying in an air
Yeah, it's
mass.
too bad when you're going west, southwest, you never move east.
Everybody has accelerated to the new tangential velocity without any issues whatsoever. It doesn't matter which way the runways are pointing, because the change in this tangential velocity over short distances is almost nothing. Less than a few inches per second.
Almost nothing.
It's
Well,
1.5 miles per hour.
When you're going west and south only, you're not going to pick up any eastward momentum.
I'll give you a value.
You wouldn't pick up any east.
Hey, shut up.
Banking eastward's not going to get you more eastward to begin with.
Shut up.
Well, when you're going west southwest, you're not going to get any more eastward momentum. So sorry, it doesn't work. Sorry.
Shut up, Whitsitt. Can you give me a hand with this guy, please? Whitsitt, you got to help me out here, man. He's really.
Oh yeah, help me out, Whitsitt. Help me out.
He won't stop talking.
Dumb now. Please help me.
Okay, so how is screaming shut up in the middle of someone else somehow?
That's what you said to me, and it works. I always quiet when you tell me to shut up. So I'm telling him to quiet because I'm going to tell him really, really quick.
Oh, he's going to keep saying the same bullshit and hopefully
the one thing that he's missing, he keeps on forgetting, it's this discrepancy in a tangential velocity along its path is equal to a 1.5 miles per hour crosswind along its path. That's it. It's not that big of a deal. Yeah, it's equal to it. It's not a crosswind. It's not the wind that's acting on you. It's the change of tangential velocity. This change of tangential velocity is real, and it's only real with respect to the surface, because from an inertial frame, there is no change in direction. You are going in a straight line unless you're actually curving it.
Man, you showed him.
Yeah, really showed me.
Two different things happen.
When you go west southwest, you have no way of gaining eastward momentum. Sorry.
I told you I have drawings for you. Let's not air your dirty laundry here.
Oh yeah, where's your drawings, Zanick?
It's embarrassing for you, not for me.
You tell me.
I'm going to disengage from you in perspective, because you just it's impossible to talk. At least Wits and I can have a conversation. You're still talking as I'm talking.
Oh yeah, okay.
Even now you are. So I'm done with you.
You make him look dumb too. You're good at it. He's better at it than I am. It's pretty easy though.
Well, Zanick just came out of the closet as a moon landing denier, so this is kind of weird for me. I'm just gonna show him.
That's not true.
Yeah.
Why did you say it?
That is true.
Zanick did not say that he's a moon landing denier.
Well, he claims they would have had to do something that they didn't claim they did, and the video doesn't show them doing. So, yeah, he's denying the moon landing. It's awkward.
Now you try it. I already got done telling you. I'll do this one more time in a 5-second version.
You said that they accounted for this the moon spinning underneath them.
I never said that. I said the Earth.
Yes, you did.
I said the object is spinning. I said if you were in a hypothetical north to south great circle route, they would have to account for it spinning ahead of the object, or that the Earth or the moon is spin underneath them. But they don't do that, because if they did, they could do it with the thrusters. What I said was that they're spinning around the circumference of the moon, with the spin of the moon, and all they have to do is slow the object down, which has a centripetal force of its weight on the moon, and it has a velocity given to it by the orbit that was given by the when it's released. So at 2,000 miles an hour over the spin of the surface, and it slows down from 2,000 miles to 0 on the surface, even though there's a 10 miles an hour difference. It spins once every 27 days. Big deal.
So they were actually going 10 miles per hour when they landed?
Pardon me?
So they would have to be going 10 miles per hour when they landed.
From an inertial reference frame, yes. But from a non-inertial reference frame, no.
All right, as the lunar module goes down, it doesn't go from 2,000 to 0. It would have to go to 2,000 from 2,000 to 10.
Well, then it's going 2,010 miles to 2,000 to 10 miles an hour. How about that?
But it didn't do that. Or is that what you're claiming it did?
That's exactly what it did.
Oh, show me telemetry data where the lunar module was going 10.8 miles per hour when it landed.
No, the telemetry data shows the radar that's used to tell its speed, which is relative to the surface, not the inertial reference frame. Dude, you are so confused on every level. It's uncanny.
But he's just pointing out.
No, it's just wrong. I mean, anyone listening here.
What he's claiming is that when it went down and said 0, it was actually going 10.8 perfectly relative to the latitude of the moon.
It's like teaching a monkey how to do chemical biology, molecular biology. It's unbelievable. You guys are.
It doesn't work, so I'll call people monkeys.
No, I said this is like.
Account for the
I didn't
orbit
call
at
you
all.
a monkey. I said this is like teaching a monkey how to do.
We have professors currently conceding this, by the way.
Who
it's like a monkey trying to explain something that doesn't work, but he has to keep repeating it.
What's it? I can't hear you because your fucking asshole friend.
Professors.
You too.
Professors said they've never thought about this, and they'd have to get back to us.
Who never thought about
especially with the orbit.
Who never thought of this?
I just told you.
I couldn't. What's it? Perspective was talking all over you. What did you say again? Like a normal human being.
Doesn't matter.
Who said that they had to think about this?
Professors.
What professor?
A couple of professors.
I'll call him tomorrow. Give me his number and I'll call him. Idiot, too.
That's going to happen.
I'll call him tomorrow. Call him idiot.
Yeah, seriously. That's not the first time I've done that before.
A Berkeley professor of dance theory didn't understand.
Yeah, in Boston, or we're talking about Berkeley, California?
I'm teasing.
Probably Berkeley, New York, right? Or Boston? Yeah, Berkeley, Boston.
You guys think that that the lunar module starts coming down, descending to the moon, and its weight in 1/6 gravity is pulling it along the moon's orbit?
Yes.
No, the momentum that was given to it by the command module is what's pushing it, or is keeping it along. It's falling, it's free falling, and it's got a tangential velocity given to it because it has momentum given to it by the command module. That's nothing unusual about that. So it's falling because you start decaying that orbit, so it's falling down more than it's going around, because the command module is still going around, and it starts going faster and faster and faster toward the surface, and then they start throwing out the jet force, which slows it down until it's going with respect to the ground 0. And when it's going 0, it then sets down gently, and then it runs out of fuel if it would have lasted 15 more seconds. That's how much fuel they had.
Did they only get the speed relative to the ground, or did they get like air relative to like the pressure around it?
What do you mean pressure around it?
Well, airplanes get their airspeed, so why would they not know their airspeed?
They don't have air to get speed from, dum-dum.
That's why I said the pressure around it.
There's no pressure around it.
There is some pressure.
There's no pressure.
Wrong.
10 to the minus 10 is no pressure.
Okay, so the surrounding area, as in from its own frame, how fast was it going? Relative to space.
Relative to space, there's nothing to measure it within space. There's no molecules. There's no atoms. There's nothing there. It's 10 to the minus 15, 10 to the minus 16 torr.
Okay.
There's nothing there to measure. You couldn't measure anything you wanted to.
You believe that the lunar module came down at an angle?
Are you asking why the pitot tubes aren't working on the lunar module? I mean, that's insanely stupid. You know that, right?
So you're claiming that the module is coming down, angled, speeding up, and banking relative to...
Why is it banking?
It has to be going at an angle.
Why is it going at an angle?
What angle did it measure? Did it land relative to the equator?
Perpendicular to it when it landed.
It landed perpendicular to the equator?
Down.
Dang, it was landing north or south relative to the equator?
North or south? No, I'm talking about perpendicular for the tangent. It'll be at one spot. Tangent is a point with a straight line that touches the surface at one spot. Its landing is perpendicular, a vector straight down, perpendicular to that tangent.
If I draw a line around the equator of the moon, where did the module land relative to that line?
Where did it land? It landed on a tangent.
Like in which direction? It was going along that same line of the equator. It was moving in the direction of the on the line.
Yes, it was following an arc path around the equator because it has a centripetal force, which keeps it in an arc path. That's a centripetal force because you know why? It had a velocity of 1,000 miles an hour when it started with it, and as it started going down, that decayed. But that was the centrifugal force not matched by the centripetal force, which was higher, so it pulled it down, and that's what they called it a free fall, somewhat of a free fall.
It wasn't free falling just straight down though. I mean, it was moving at an angle.
Oh, it had a vector straight down, yes. Unless they had jets falling, it was
Down relative to center of the moon.
No. It's
Yeah.
just because it's moving. Again, relative motion. You have a vector down, which is the centripetal force.
Relative to center of mass.
Relative center of mass, and you also
Why'd you
have
say no then?
hold on. You have a momentum. Which way is this momentum moving? Moving at more of a down outward direction, at like a 45-degree angle, let's say. So even though you have a vector down, which is its centripetal force or its weight, you also have a vector that is its momentum, which is also moving in a certain a circumference around the moon. Not quite, because it's actually now decaying, so it's a little more inclined. So it falls down, but it's like when you throw a baseball. It has a vector down, but it also has a vector outward. And it also has a vector that's force acting against it as well. We call it drag. But if you had no atmosphere, you throw it like on the moon. Throw a ball, it'll have the same kind of vector. Throw it, it has a momentum outward, and it has a force vector down, straight down.
Okay, so if I had a drone that was electrostatic and I hovered it on the moon, what would happen?
Nothing.
I should be able to just hover the drone,
Yes.
and the moon should come back to where I started.
No, you have momentum when you take off. This is where you got in the problem with the Volca pendulum was on the North Pole. You couldn't figure out why the independent frame of reference gimbal wouldn't allow this hanging, not swinging pendulum to rotate.
This is hilarious.
You don't understand momentum. So no, if you take off from the moon, you retain the momentum given to you by the moon. Whatever that tangent velocity is, the 10 miles an hour.
Matthew, do you agree? Matthew, what is your answer? If, say, I had a drone on the moon and it's electrostatic, and I hover the drone above the moon, is the moon going to move underneath me, or is the drone going to move in lockstep with the moon? Or is the drone going to move?
It retains its conservation of momentum is still true on the moon.
Retains momentum. Keeps its momentum.
Wow.
Plus, electrostatics is a completely false debunked theory, so I don't think it's on the moon either.
What?
Some people say that there's some fictional electrical potential between the ground and up high in the sky on Earth, but that's false, and it's also false on the moon.
Wow, you can't even read Matthew or Richard Feynman from your own religion and realize that what you just said was really stupid.
Are you talking about the 100 volts per meter? Is that what you're talking about?
Yeah, he just said I made it up.
No. He's talking about any kind of force he would have or any kind of influence would have over this scenario.
No, he just said that there's no current going down the Earth. Anyway, actually, there's a free space impedance of 377 ohms with an electric and magnetic constant even inside a vacuum.
Okay, so then we see some current flow if that was the case. Do we?
Are you denying free space impedance?
Wow, so we could have free energy by just sticking my electrical cord up in the sky high?
Yeah, just go ahead.
Wow, you guys are denying free space impedance and then making fun of me. But you guys are not even close to that level, though. So
no, we're making fun of your understanding.
What's free space impedance? Then correct my understanding, Matthew.
I don't know what it is.
Then how can you correct my understanding?
Based on my experience of your ability to understand things well.
Hey, you got nothing.
He's got a good
of
point.
your ability
to
understand things.
Okay, real quick on your drone. So you understand that, but Matthew and I both have told you that this thing retain its momentum. So as soon as you leave off whatever the mechanism, statics or thrusters or whatever you got, it will stay in lockstep with the moon because the moon gave you the momentum. It will give you the momentum, and it will not rotate underneath it. Now, if you went straight
move against the direction of the moon,
no, it'd be going with the direction of spin because
even if I go, what if I move against it?
Whatever momentum you were able to generate by moving means you're insinuating you had some acceleration, you had force. So whatever that force was will be retained also. So you go some direction with a force, and you turn it off, you will continue to rotate around the Earth if there was electrostatic propulsion that didn't have any kind of force acting against it, and you would basically orbit around the moon.
So if I went east or west on the moon, it's going to be the same.
Yeah, why wouldn't it be?
Well, you guys claim that the atmosphere moves in lockstep with the Earth, so the planes move with the Earth because of the atmosphere. But then you also claim that the module on the moon does the same thing without the atmosphere.
Yes, it doesn't need any atmosphere. The Earth, again, both those, that's a non sequitur, first of all. Number two, it's almost a straw man, too, because you're talking about something that has little or nothing to do with its ability to continue in motion in every direction. It's been from Newton's first law and second law. These things will go in motion until acted upon by other forces. So there's no reason why it would actually change directions. And all it has is a centripetal force, which is its weight, and you have a thrust downward or electrostatic that's acting upward. So there's a balance of forces. So it will, whatever way you send it, it will continue to go in that direction, regardless of the spin of the Earth, regardless of the direction you're sending it with respect to the spin of the.
And why would we be going in an angle, moving in a direction instead of just going down?
Because it has. Are you fucking with me?
No, why would they be actually making the module go at an angle and move in a certain direction?
Why would they just drop it down?
If just the weight itself was going to bring it around the moon perfectly.
Are you saying why wouldn't they just drop it straight down? Is that what you're asking me?
Because it'll look like it's straight down to us according to you, but it'll actually be pulled with the moon.
No, because it's going. That's like saying jump out of the ISS and try to go straight down. Why do you think when things come off of the ISS, they almost burn up in the atmosphere before they land in the ocean? Because you have to scrub off 17,000 miles an hour.
And an atmosphere, that's completely non-analogous at all.
It is. So on the moon, there's no atmosphere, but you still have this momentum that's retained by whatever orbital speed you have, which is around 2,000 miles an hour. And you have to scrub that 2,000 miles an hour, or minus the 10 that for the rotation, and then you end up landing on a zero velocity with respect to the ground. By the way they measured the velocity with it, if you want to know the real answer, they use radar. The radar tells you the speed they're going, not measuring pressure, as you said, around the lunar lander, which is just insanely absurd. I think that's what makes me think you're fucking with me, because you're saying really dumb things.
No, none of it happens. None of us think that, or at least a lot of us here don't think that it ever really happens. So these are all just theoretical things that they're either claiming or are wrong about, and you're either wrong about or claiming. And regardless, none of it happens. So that's the most obvious to all of us, at least most of us here. None of it ever happens. So that's just so funny to hear you act like it does happen and act like we're confused about how it happened, as if it really happened, but it never happened.
That's he keeps on saying he thinks that when you leave the ground, just like Nathan Oakley and Nathan Thompson, that suddenly, if Coriolis is real and the Earth moves underneath the focal pendulum, then if I go up in a hot air balloon, the Earth should rotate underneath me. They forget this, and for some reason, the conservation of momentum law is something that escapes them completely and entirely. It's almost like
that's the problem, it doesn't exist. Even if we give you that, when you go over the gradient of tangential speeds, you can't claim that conservation of momentum is going to somehow meet the new tangential speed. You act like it's an easy thing, but it doesn't.
You're right, it won't.
It won't. At least you admit that.
Hold on. The only thing that really fights against
you're going to shit on a left.
You're doing it again, and man, it gives me a headache when you do that. So just stop, please. If you have any decency whatsoever, just stop talking over me, and I'll do the same for you. Thank you. So what I'm saying is that when you do hit south, if it is just the atmosphere that's helping you, it's very slight, because we got to realize that it's equivalent to like a side wind, a crosswind that's 1.2 miles an hour, 1.5 miles an hour, acting on the entire aircraft's side coefficient of drag picture, and that force would be very small. It would not be able to suddenly move the entire airplane 1.5 miles an hour to the side. It will over time have an effect, right? But it doesn't move it. It doesn't move step. It's one very small force that will be acting on the plane as it changes, goes through an area of higher or lower tangential velocity.
Okay, now I'm going to ask a question, and don't interrupt me. The question is, if you're going south and you have to correct east by banking east direct when you're going directly south, if you're banking east to somehow get the plane moving sideways, which there's no gauge to even know exactly how much it's moving sideways along with the Earth. They have no idea how fast the Earth is moving below it. They don't even think about it. Left lane's never trained for it. But just to beg the question and assume that if it was moving and you have to bank east to get the plane moving sideways as it's slowing down to land, somehow moving sideways at 1,000 miles an hour, maybe 500 miles per hour more than it started out with at its original latitude. Now, if it goes only west and southwest, how does it get eastward momentum when it goes towards the equator?
Not a problem to answer it whatsoever. If you let me speak,
Yep, but answer it.
I will be more than happy to answer that question.
Momentum. Everyone listen for how he explains very clearly how it gain eastward momentum. Listen very clearly how it would work. Eastward, directly eastward momentum is what we're looking for here, everybody.
Okay, you let me know when you're done talking, and I'll respond.
I'm done. Go ahead.
Okay. So if you were a projectile, an unguided projectile, you would be traveling southward, and you would be off course by 500 to 1,000 miles to the west if you were just on a non-guided projectile route, because you're ending up at a tangential velocity target that has got 500 miles an hour faster, greater than you took off from. And in order for you to do that, you'd have to gain momentum out of this thin air, and that breaks the first law of thermodynamics. Breaks that pretty solidly. You would agree. So how does it gain that momentum? How it can't be created nor destroyed. How do you gain momentum? Well, you need a force to do that. So what is that force? Well, the force is what the airplane acts on the air with, the atmosphere with, by bending the wings, tilting them a certain direction, adding a little rudder, little elevator, and you start making a turn toward a new destination, because along the way you make small changes because you're going point to point to point and trying to follow a targeted path. And you're going to be running into crosswinds along the way, which are far in excess of this issue. But barring that, not even talking about that or addressing it, you don't just fly a plane to a direction. You get there and suddenly find, in fact, this can't happen, by the way. Can you hear me? Because my computer's giving me problems again.
Just tell me. I want to hear how you're going to gain eastward momentum. You don't have to go through all the scenarios.
I won't be able to finish. Seriously, hey, buddy, I won't get, my computer's going to go dead here in a second. It might bounce me. Before it does, I want to get this out. So you can't end up someplace. You can't end up someplace and have it a 500 mile an hour tangential difference. So what happens along the way, you tangential velocity by turning to the east. Every mile, every 5 miles, every 10 miles, you're making small movements to the east. So by the time you have a 15
hour plane's only going west and southwest. Just to let you know that was in the scenario. How does it go east? I said west, southwest.
You said specifically south. You said going south.
No, I said west, southwest. Why are you trying to change it like you always do?
Yesterday. You didn't say it today.
West, southwest.
We'll play the tape. No, you didn't. No, you didn't.
You said south. You have to change it to south because you have no answer for west, southwest.
I have an answer.
You're going to give it instead of trying to change it like you always do.
You're flying. You mean west, southwest. That's what you meant to say, right?
Yeah, that's the meme.
You didn't say that, though. You said south.
I said west, southwest very clearly many times over the last 5 years.
It doesn't really matter. Either way, my answer is the same.
To you, west,
so
southwest,
my answer is the same. Can I finish?
How many times do you have to hear it?
You said you weren't going to talk.
You're obviously
lying.
You have no answer.
Okay, I'm not going to answer you now. You're just an asshole. Let me know when you want me to talk.
No answer.
Let me know when you want me to talk.
He's running away, everybody. He knows he can't gain eastward momentum when the plane only goes west southwest. No one has an answer for that. That's game over.
All the plane has to do is lose some westward momentum, and he gains eastward momentum.
Technically, you're right, but not enough to gain on top of that. If he's going west, he's going to lose the eastward momentum he already had. Because if your philosophy is banking east adds momentum,
let me know when I can talk.
Going west is going to make you lose the momentum. Zanick's already admitted that.
Let me know.
But now you've lost eastward momentum just by going west, southwest, west, southwest. Don't change it, Zanick. Go ahead.
Okay. So even if you're going south or southwest or west southwest, regardless, you are traveling at some component of south. The distance is known. It doesn't matter whether you get there the long way or the short way, going directly south or not, you still have a southern component. That southern component will experience Coriolis. And that's where the tangential velocity will be higher at your targeted location. And to get there, you're going to be slowing the plane down, and you'll be turning eastward along its path. Even though you're going south, or even going west, you're You'll still
west,
be going a
southwest
little.
only.
Actually,
Eastward, you're going
as I
west,
said in my
southwest.
text to you, even I
But
said
no
you'll be
eastward
going.
component
You'll be
there.
making. Hold on, let me. Who's saying that? Listen, you'll be making slightly left turn. Forget about east. Now we're going
What's
more
left?
south. Could be even directly south. You'll be
What
making.
does left?
Oh my God! Can you just keep that mouth shut?
Why does left have any context when you're talking about
Everything
west,
is
southwest?
all the Coriolis does is make you turn. It makes objects appear to go right. Everything goes right, no matter what direction you're going. Over a spinning ball, it always is right in the northern hemisphere, spinning counterclockwise. You understand? Always to the
Okay.
right.
How is
So
the
we keep
plane
on
gaining
making.
eastward
So
momentum
all
when it
we
only
do
goes
is.
mostly
So
west,
let me
slightly
finish.
southwest?
Said you were going to shut up. I let you say every word without talking, and you
You
can't.
haven't answered. You have no answer. It's just
I'm
hilarious.
answering it. You won't let me speak. Obviously, you're scared.
Oh yeah.
Well, obviously,
I'm so scared.
you're terrified.
I've just asked you a million times.
The answer is very simple. As I follow this point-to-point
So simple.
path going west southwest, I'm going to continually be making leftward.
Leftward. What's leftward?
Left. We're going to
What's
be
left?
turning the plane left.
What's left? What is that? That has no context when we're talking about different
It
angles.
could be south.
Don't say left.
It could be south.
Use
It could,
east.
depending on where we
Use
are.
actual
South.
directions.
It's going to be south. We're going to be hitting southward type of motion.
Okay. So southward makes you go
South.
eastward more.
Southward. And
So you're saying southward makes you go eastward more.
Yes.
Wow, that's news to us. I guess everybody here is probably pretty surprised about that.
Everything,
Just
because you're
turn
going
left,
west.
south,
You're
and
going
you gain
west.
Eastward momentum.
Because you're not going south. You're going more west than you are south. So every motion you move has to be toward the south. You can't go east, right?
Not at all.
So all you do is go south. So all you do is go south.
That's the point. No, you have to go south. Yeah, south doesn't gain eastward momentum.
You're not getting it. You're just talking, and you're
I'm not getting that.
You're panicking. You're panicking.
I'm not panicking. I'm just pointing out the obvious.
By taking a left turn, by turning slightly south.
Left is south now?
Some degree of south, toward the south.
So banking south gives you directly eastward momentum. That's your quote.
Yes.
Just banking south gives you more eastward momentum.
Correct.
Well, if that was the case, I'm sure that would be really useful for people.
That's how they go along the way.
I had no idea.
Let's think about it. Let's think about what happens. So we're flying toward. We're going from. Let's make it real simple. You said Chicago to San Diego. Well, we leave Chicago, going directly. Now we're going west southwest. So we're really going toward like San Francisco. Let's say pointed towards San Francisco. We want to go to San Diego. So how do we make up that tangential velocity of, I don't know, 100 miles an hour, 50 miles, probably 50 miles an hour, right?
That is the question.
Okay. So what we do is we start flying. For the first leg, we don't even close our eyes, point our plane to San Francisco, say we can see it because the Earth is flat. We can see it, or we know we're told in, and we have an infrared photography, and we actually can see 2,000 miles. So we see San Francisco, we point right directly to San Francisco, and we go 100 miles. But we notice now that we are off. We're too far north because the Earth is now rotated, and we have now moved. Our trajectory is now more towards Seattle than San Francisco. So at 100 miles, we bank to the left. And then
left
we keep
what?
Another 100 miles. We notice the same thing happens again.
Wait, left is what?
We bank left.
Left is south. Left is south, and south.
We go 100
banking
miles.
South now gives you eastward momentum.
We're going west. We see we're aimed to San Francisco. We close our eyes and just travel. We wait. We open our eyes at 100 miles. We notice. Actually, let's get more real. We're pointed toward Reading. So we say, we don't want to be toward Reading. We want to be towards San Francisco. Why did that happen? Well, because the Earth is rotating this Coriolis. So we point the airplane to San Francisco. We made a slight adjustment. Close our eyes again. And every 100 miles, we do this.
Close your eyes? What are you talking about? Close your eyes. Why are you saying close your eyes? That's hilarious, though.
We're making a trajectory. We're not making any changes to the controls. You know why I'm saying this. Don't be an idiot.
Well, I thought you were kidding. Like you just close your eyes for what reason? You're banking south to go east. How?
But don't we want to go?
This is some kind of newfangled flying lesson.
So we end up at San Francisco with all these small adjustments. We now are right going toward San Francisco. We are going an airspeed that we want to be going at. We are at a direction we want to be going, but we want to go to San Diego.
Really?
So now we get to San Diego, we get to San Francisco because we wanted to go west, southwest, and now we have to go from San Francisco directly south to San Diego, which is not a problem. Same thing happens.
So you think that was an answer? How did the plane gain 500 miles per hour eastward momentum when it never went east ever?
Because we made southward corrections.
Southward corrections make you gain eastward momentum now.
Correct.
I didn't know. Is that possible? Is that really possible? I mean, that doesn't make any sense.
I know.
Does that really make sense to you?
Because you're a halfwit.
I have no idea. I had no idea south is east.
Yes.
South and east are the same things now, huh?
No, south.
Well, you heard it, folks.
You're correct.
South is now eastward.
There's no difference. There's no difference.
No difference. You're right. No difference. I thought there was.
Hey, shut the fuck up. There's no.
I know. I did. I was confused. You're right.
Shut up. There is no difference between doing what I just told you in a very simple terms, first grade lesson, or going south and making small corrections to the east. No difference at all.
Oh, wait. South. Wait. Going south. Wait, you said we're going south and making corrections to the east, but we're talking about west, southwest. Now you've changed it again.
Right. No. I said there's no difference between going south and going east or going west,
okay. There's no difference between south and east.
South.
You're right. I was confused. You're right. I had no idea that south and east were the same thing. No wonder I was confused.
I don't know if there's any help for you.
Thanks for making it.
Jeremy
clear.
said on the private, he goes, perspective will never concede ever, no matter what you say. He said you'll never. And he's probably right. I could show you a demonstration.
I don't know if Jeremy understands it because he said yeah, he's getting lost in the sauce. But I think he listens to you and thinks that you're actually trying to tell the truth rather than just excuse the ball. Maybe.
No,
he's confused. Maybe he thinks that you actually think it's a spinning ball. I don't think you think it's a spinning ball.
One of the other ways.
I'm actually giving you a compliment. You have way too much common sense, to really believe it. I don't think you do. Because what you just said is that south is the same as east. Now, if you really believe that and you think it works that way, then, Jeremy, you should just listen up, right?
Yeah. But
you should listen up. West, south, and east are the same thing, everybody. That's why I was confused. I'll admit that. I had no idea.
Well, one of the things you'll do along the way also is you might notice that your speed is increasing with your ground speed. So you'll probably start backing down the throttles as well. When you start slowing down, that also increases your tangential velocity. So you might have to.
You're right, Zanick. You really put me on my place because I was thinking that south and east were different directions.
Well, no, you're doing a combination of slowing the plane down and turning south. Combination of those two vectors, the forces acting on those two vectors will increase.
Even though you admitted before that you would lose eastward momentum, the original conserved momentum, you would lose a lot of that just by traveling west for a long period. So now you've lost that original 500 miles per hour tangential velocity. And on top of that, you need 1,000 when you get to the equator. How are you going to gain more when you've already lost?
We're not going to the equator.
And you can't even bank east, like you said when you go south. You have no bank
east. Dude,
you
don't stop talking to me.
It takes your bank east excuse out of it. You're saying south.
So how are we going to get to the equator if we're going west southwest? How's that possible?
That's the whole point, Zanick. You're going west.
We'd end up probably coming all the way around the entire Earth before we end up hitting the equator, right?
It's just a fucking thought experiment that doesn't make any sense with the globe, dude.
Try going from Chicago to I don't know, New York to South America's on eastward.
Zanick, what are you worried about? You already explained it. You explained it very clearly. South is the same thing as going east. So I didn't know that.
Because you gave a scenario where it's very difficult for you to understand. I understand it.
It's about me not understanding the scenario that you just explained very well. South and east are the same things. I had no idea. No, seriously, I'm all cleared up. I totally understand now. You totally made it. I was confused. I thought south and east were different directions.
When you're done.
Now that I realize they're the same, no reason to continue on. No reason to even explain further. I was confused. I thought south and east were totally different directions, but they're the same according to you. So You can just bank south, and it's as good as gaining momentum eastward now. I didn't realize it worked that way, so maybe that's just all you need to say. Why continue on, right? Makes perfect sense to everybody, I'm sure now.
So a better example might be the easy might be to just go southwest. So you're still going west, but you're also going south. So all you would have to do along the path is to go southern type deviations and slow the plane down. The slowing of the plane down along the way, slowing the plane down along the way will, and the atmosphere will do some of this, by the way. Slowing the plane down along the way will increase your tangential velocity. There's no difference, just like there is no difference in acceleration when you're going up and going down. You can always still have a downward acceleration even when you're going up, like in the Baumut comet. Same thing happens when you're going southwest. Even though you're going southwest, all you're making is small deviations to the south, and you're slowing the plane down. Both of those would change your tangential velocity to the east. Now, that is a simple explanation. Let me summarize by saying that is a simple explanation. I've given you everything you need to figure it out. I'm hoping you'll take me seriously and draw on a piece of paper and understand what I said. Plane down along the way.
Well, all I have to do is write down that south and east are the same thing.
You can't help yourself, can you? You just can't.
No, you explained it. I appreciate it. You cleared it up. South is the same thing as east, so we're all set.
I said south adjustments and slow the plane down periodically.
Oh, okay. So you start out with 500 miles per hour eastward momentum. That's conservative. You lose a lot of that because you're traveling west and south. And then somehow, just from slowing it down and banking south, you're going to gain 500 miles per hour more than you originally had by the time you get there. Wow. If it was that easy, then I should have just realized
I hope
it's
recorded.
You don't even have to worry about going east at
Stop
all to gain
talking so I can respond to you.
No eastward direction, no eastward acceleration, none of that to go eastward. You want to gain eastward momentum? Come to south. Just go south and slow down. Don't worry about it. You get 500 miles per hour more eastward momentum, no problem. Yeah, just the south is the same thing as east. Don't worry. It's all good. It's all good. Don't worry about it.
Nice job. I'm really happy. I mean, this is the happiest day I've had.
I'm so happy that really is a satisfying answer.
Slow the plane down.
If that satisfies you, then you are the most hilarious person right now at this very moment.
So I've been trying to get a word in for 5 minutes now.
You really want to keep going? I mean, you already explained it.
I do. I want to thank you. So shut the fuck up for a second, please. Thank you.
You're welcome.
So I'm very excited that you figured it out. You repeated it correctly. You're mocking it. Can you shut up?
Can I quote you on this?
Just let me speak. You're giving me a headache. This is fun, except for the headache. So listen, you got it right. You slow the plane down and you turn south. Right. You have the answer, and you're progressively doing that the entire way as you travel southwest, and it will increase your tangential velocity.
Easy peasy,
you can't help yourself, can you? You're so fucked. I can't believe how fucked up you are.
I can't believe you're getting mad. You already gave the perfect answer.
Were you on the short bus? How long were you on the short bus for?
It must be that it was a short bus. I didn't. You know what? You're right. Because in school, I was learning about east and south, and I thought they were different. I took the short bus.
We're talking about something a little bit above kindergarten. We're talking about Coriolis.
Yeah,
we're talking
south and east are the same.
And yes, don't say anything, please, for another 10 seconds. Try to bite your tongue. We're saying that if you're traveling southwest, you'll be turning southward, and you will maybe making pull back throttle along the way, changing your velocity, changing your speed along the way. And in the end, over 12 miles, 15 hours, whatever, after 15 hours, you will have increased your tangential velocity relative to the eastward direction of the spinning Earth.
So then, by that logic, you're traveling directly south. You must be gaining a lot of eastward momentum just by going south.
Exactly. You broke the code again.
Right?
2 in a row.
Yeah.
Dude, congratulations.
Yeah, so why would you even need to bank east, right?
You don't. You just need to bank
east. If you bank east, you might be going too much more east, right?
No, you bank east. Did you say that? I thought you said bank east. Yes, bank east.
No, I said if you're going south, by that logic, then you'd already be gaining eastward momentum just because you're
no.
south.
You have to make it. You have to change the direction.
It doesn't work that way.
So I thought you said
you actually bank east to get more eastward.
I thought you said east. Yeah, you got to go east. You got to go east.
Okay. So you got to go east, but then when you're going west, you just got to go south.
No, you have to slow down and you have to go south.
Slow down and go south. Yeah.
Yes.
Then you can actually catch up to the 500-mile tangential velocity that you were missing from the very start, even though you've lost some of that from going west. But then if you're going directly south, you really have to bank east because you need to catch up to the 500 miles per hour. Good thing you didn't go west. Oh, wait, no, if you went west, just slowing down gives you the extra miles per hour. But there's no contradiction there.
You wanted to get to an object south-southwest. Did you want to go straight? Did you want to go straight south? Then you're really fucked because you'll never get there. By the way,
Then you're really fucked.
but no. But what I'm saying is you will get the tangential velocity. You're thinking.
The point is, you're really fucked. If you're thinking about it all, that plane would be out of sync with the Earth at all, just tell fucking left lane that that's an issue, and he will never fly again. I promise you. If he thinks that's true, and he can't just go up in the air and not worry about banking east or banking south to go east or any of that, I don't know if I wouldn't fly if I thought that was something I wasn't trained to figure out.
You realize the air that you're flying in is a factor here. I mean, leaving some things out because
The air now. We're going back to the magic.
Well, because planes. I don't know if you know this, but planes fly in air. So here's the interesting.
Air.
Here's an interesting thing about this
crosswind in every direction.
Well, yeah, it is true. But the air mass in general, down at the equator, will have a 500 mile an hour tangential velocity higher than when you left. So think about
the
ramifications of that. What would happen if you were now flying and going toward a higher tangential velocity air mass? What happens? You're not fully thinking this through, by the way.
Oh yeah, I haven't thought it through. You're right.
You're really not. You're really not.
You're right. I was totally under the assumption that going south.
Another way to look at this
would not allow you to gain.
Another way to look at this,
because when you're going south, you need to bank east to get eastward momentum. But then when you're going west, all you have to do is go south and slow down, and you gain just as much.
So you don't want to listen. Okay, I'll just let you talk for a while.
No. I heard you. I was just explaining how you explained it to me, and now that I'm totally cleared up, there's no reason to have to explain anymore. You did a great job. Everything's completely clear. Everyone listening should totally be understanding it without any problem now. South and east are the same thing.
No, I said turn south and slow the plane down.
There you go. Slow down. You wouldn't have to worry about it. Because when you're going directly south, you have to bank east to actually gain eastward momentum, even though that doesn't work either. Even that doesn't work, which is the most hilarious thing, because you never think about the Earth turning below you. You're never out of sync with the Earth. The plane always lands on a stationary Earth because it's stationary. That's the only way that would ever work. If you ever had to worry about being out of sync with the fucking Earth, you would never fly. And you would never fly without having special aircraft carrier training at the very least. And they're not trained to do that. None of the flight simulators, including moving Earth, there's no gauge in the plane that says the Earth is going this much faster than your plane's moving sideways. So therefore, we need to gain more eastward momentum. So now you're going to bank south and slow down to do that somehow. None of that is included in the training, and it would be if that was actually happening, which is the point.
All you're doing is flying from point to point. You're making small corrections to
the point to point.
Has moved.
Rescue yourself with the point to point, like that just solves it.
It does, because if you're going traveling southward,
why worry about tangential velocities? It's just point to point.
You don't have to worry about it. Exactly.
Yeah, don't worry about it. Yeah, so don't even worry about banking south and slowing down.
Along the way, small changes will be big changes over 15 hours. Like I said, it's
but it's just no reason to worry about it. Right?
A 1.5 mile per hour crosswind along the way. That's all it is.
But you explained very clearly that would be a big difference in tangential velocity by the time you get there. But don't worry about it.
Because you've accelerated by making left turns as you're going south.
Well, how would he know to make left turns while he's going south if he's not worrying about it?
You'll be off the target.
Well, but the target doesn't solve it. It doesn't matter. The target could be like he goes way south, and then he's like, oh, I'm off my target. I'm going to go north now to get my target. You have to correct that way. No, now I didn't go south enough to catch up to this tangential velocity. How do I need to slow down in case I'm not going enough eastward? Now, wait, hold on. I get there, and then all of a sudden the ground's moving faster than my plane is moving sideways. Better put on my side thruster so that I can gain 500 miles per hour going sideways and then slow down to go into a north runway. None of that ever happens, Zanick. You're fucking full of shit.
Let me guess. Zanick is trying to explain globe math, but it doesn't happen. It doesn't work out in reality because people really have to
Because
fly.
it doesn't actually happen. Yeah, there's no one has to worry about it. No one's trained to worry about it, but there's all these complicated things he has to worry about explaining as if it was something to worry about, even though no one worries about it.
Zanick, do you think that any pilot ever has had to worry about the Earth?
Pardon me?
Do you think any pilot ever has had to worry about the Earth spinning?
About the Earth spinning? No.
Oh, okay,
Yeah,
yeah.
No one flies that way. No one flies.
No reason to
no one
worry
flies
about banking south to go east, then, right?
because you don't have to. You don't got to worry about it because who flies south to go east? You said you're flying southwest.
Otherwise, you would have
west,
to worry about it.
southwest.
But you don't have to worry about it because
Well,
the
you
Earth
fly,
is stationary.
so you fly south. You fly southwest when you're flying from like Alaska to Hawaii or from Seattle to Hawaii. So how do they get there? Let's do some math on that. They're flying into a tangential velocity that's increased by say 100 miles an hour. Would you agree?
If the Earth were spinning, that would be the problem. But no one has to worry about it because the Earth isn't spinning. Is the point, Zanick?
Mm-hmm. Well, they're
So
traveling.
why even worry about your little thought
traveling
experiment?
south. They're traveling southward, but they keep on making a southward direction change along the way.
Really?
Because of Coriolis. Now this
So they do have to worry about it.
Why would you worry about it when it's so small? All you do is you match.
Well, yeah, because a small difference makes a big difference when you're in an airplane.
You're using this. If you didn't have navigation systems, you'd be using the stars to figure out how to get down there, and you'd be backing that up every so often with the directional change. If you have radar and you have checkpoints along the way, satellite GPS is what they use. That will be able to track your position exactly to where you want to go.
So
Also,
if you miss your checkpoints, you're fucked. You're going to be out of sync, huh?
No. Well, if you're off, you make a correction. A small.
Oh, yeah, you better make that correction. Otherwise, you're going to be fucked,
autopilot
right?
does that. Autopilot does that automatically.
Autopilot. Oh, good thing for autopilot.
Well, no, you don't need autopilot. I don't.
No, you don't need that either. Yeah, don't worry about it.
You just find you have your beacons. You see where you are. You plot on a map where you're going. And a lot of it's on the iPad now. You can see exactly where you're going. And if you're off course, you just make a quick. Even in your car too, you're making a lane change. Google Maps will tell you where you should go, where you are, where you should go. Just make a little bit. Oh, you're in the wrong lane. You're in the wrong lane. Stay left. Stay left. Oh, wrong lane. It looked like it was the right lane, but I'll go more left, and it's fine. And I'm on my merry way. No problem. You make small changes along the way, and you will have no problem hitting your destination. Regardless.
Let me ask you this, Zanick. Let me ask you this: if the pilot gets to the north-facing runway when he's headed west-southwest, and he realizes that. He looks out the window and he's like, oh shit, the ground's moving eastward way faster than I'm moving eastward, right? How's he going to go correct?
It doesn't happen that way.
Well, it doesn't. Well, that's only because the Earth isn't moving, right? Because you're drawing all these scenarios where that's possible.
We have a crosswind that changes from 1.5 miles an hour per minute.
Earth moving.
If you didn't adjust,
don't conflate it with crosswinds. They're totally different.
Quiet.
Crosswinds are not the same as Earth moving.
If you didn't adjust for rotation at the beginning, and you didn't adjust at all until you got there, and there was no air mass, yes, the Earth would be rotating underneath you at 500 miles an hour.
Yeah, that's a big problem. What would he do?
You'd have to. Well, you'd be approaching this object that is now spinning towards you, but along the way, you'd have to be making adjustments. Otherwise, you'd miss it.
No, like say he got there and the Earth is spinning below him. What's
he
going to do? How's he going to correct now? He's got to get the eastward momentum going.
Yeah.
So you have to go north and then
right.
south.
So you'd be pointing. So shut up. So you'd be pointing you'd be traveling the wrong direction, and the Earth would be spinning underneath you by 500 miles an hour. You have to make a U-turn and chase after the Earth and catch back up.
You have to chase after the Earth, and then once you catch up to the Earth, you slow down to land. And how are you going to keep going with the Earth once you caught it?
Because then you'd have a zero speed when you landed.
No, you wouldn't have a zero speed because you stopped. You slowed down to land, so you wouldn't be moving with the Earth because you slowed down.
Yeah, you're moving with the Earth because the Earth is the runway. The Earth and tied together.
Yeah, that's the problem. You say it catches up, so now it's caught up.
Now you're giving me a headache.
How does it slow down to land?
You're giving me a headache because I can't.
Yeah, because you have no answer to that.
I don't know if anyone's ever told you this before, but it's very difficult to talk to you because you just keep on talking over people.
Oh, you don't have that problem. That's the only way to talk to you, Zanick.
No, I don't. I usually wait for you to speak.
Oh, yeah, you usually wait for people, right? You never talk over anyone. Now you're really, really, really making shit up.
As I just
it's hilarious. You think that the plane's
So
going
I
to go
talk and then you
500
talk
miles
real
an
quick like
hour,
you're doing now.
catch up
See,
to the
now
Earth,
you're not letting me.
and
I
then
let
it's
you
going to
talk,
be
and
at
now
the
I try to talk and
zero?
leave
Then
you
it's
go.
going to be
Keep
at
on going.
zero.
Okay, great.
So it flies to catch up to the Earth, and then all of a sudden it's zero, even though it slows down to land. You think it's going to keep moving with the Earth, even though it slowed down to land? It doesn't make no sense. It makes no sense to anyone with common sense.
Yeah, you catch up to it because you're going 500 miles an hour slower than the Earth.
Yeah, then you catch up to it, but you have to keep going. The Earth doesn't stop when
You're
you
going
stop.
backward.
When you deaccelerate, and
Decelerate?
when you slow down to land, the Earth keeps moving, and you don't because you
Yeah.
slowed down to land.
When you catch up to it, you are now going 1,000 miles an hour.
Yeah, when you catch up to it, you have to
So
keep
you keep
going.
on. This is the
You
problem.
can't
You keep
slow
on.
down to land and then keep going with the Earth.
Look,
When you slow down, the
you're
Earth
giving
keeps
me a headache.
moving, and you
I
won't be
can't
able to
talk to you
land.
because you just don't understand. Relative motion. There's an inertial reference frame and there's a non-inertial reference frame. You're getting the two confused. Every single time there's a word out of your mouth, I don't know which reference frame you're speaking.
You're running to me being confused when I just
Yes,
clearly
you are
explained that if you
confused.
have to catch up
Clearly,
to the Earth,
are you
you would
talking
have
about
to
the
keep
rotating
going that
reference
same
frame?
speed.
Are you talking
Once
about
you
the
catch up
rotating
to the
reference
Earth,
frame? Okay, never
Zanick,
mind. I'm done.
Zanick,
I'm
don't
done
talk
with
over
you.
me.
I can't
Zanick,
do it.
you're running away because you can't answer this
I'm
question.
running away
When
because
you
you
catch
can't
up
let me
to the
speak.
Earth, listen, Zanick, let me speak right now, and you can speak. When you catch up to the Earth, you have to keep going that acceleration. You have to keep accelerating in that direction. You can't slow down to land and then expect the plane to keep going at that same pace as the Earth. That's common sense, dude. It's so fucking stupid that I have to say it more than once. Yeah, as soon as you catch up, you're at zero with the Earth and you're in perfect sync. But you can slow down to land and you're just going to keep moving with the Earth because you sped up.
What we have to do is take like a beach ball and like start see if the planes can land and see how that works. Like do
No. We already know they can't land. We just very clear. Zanick made that very clear that the Earth is always stationary when the plane lands on it. He made it seem like there's something to worry about. Then he said you don't have to worry about it. So those contradictions should make it clear to anyone listening that it's obviously not happening.
If you're coming down from Mars, right? The Earth is spinning in front of you, right? And then how do you adjust to that spin then?
Well, that's the other thing. That's just like Witsit was talking about with landing on the moon. If you're going into this new atmosphere, that's no atmosphere, and then you have to worry about moving sideways with the moon as you're trying to land, and you're going straight down, and you have to accelerate sideways and go straight down at the same time, and none of that happens. None of that ever happened because they never went to the moon anyway. So it's just stupid to talk about it as far as the moon is concerned. But if it was a moon landing, then that would be a problem too. But you can't even land on Earth if it was spinning. And I just made that very clear by showing that Zanick is completely contradicting himself by saying you don't have to worry about it, but then saying all these things to worry about, saying that south is the same as east. I mean, these are ridiculous things that anyone can hear. He's calling me a moron. It's hilarious.